Hello guys, in this video we'll be discussing about one more problem based on signal flow graph. So signal flow graph, we have to find out the transfer function for the signal flow graph. For that we have the Mason's gain formula. Okay, so for using that Mason's gain formula, we'll be finding out the transfer function of the given signal flow graph. Okay, so we have C of s and R of s. C of s is nothing but the output of the system. R of s is nothing but the input of the system. So the transfer function is nothing but the C of s by R of s, output by input. Okay, so Mason's gain formula is given as transfer function equal to summation of Tk into delta k by delta. This k is nothing but the number of forward paths. So T is the, for that we will discuss. Okay, we will take step by step and let us discuss the solution of this given signal flow graph. So here we have the signal flow graph. So here we can see the nodes 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, totally 9 nodes starting from this R of s to C of s. So this node we have to eliminate. This thing is not there. Okay, so totally 8 nodes. Okay, till here. So we have till here gains here 1, G1, G2, G3, G4, G5, these are all gains. Okay, this is the feedback gain. We have H1 like this negative. Now the thing is that first step is that we have to go for the forward paths. So in order to find the forward paths, it is given by K. Okay, K is equal to how many forward paths are there. Basically we have to understand what is forward path. You have to start from R of s. Okay, starting point will be this R of s, ending point will be C of s. You have to travel in the one direction, unidirectional. Start from R of s, travel in one direction and reach C of s. This is nothing but the forward path. Okay, so I'll start from here. Direction you can see we are having each path, we are having direction. Okay, so I'll take this straight path to reach here C of s. So that's what I have given written here. You can see this. So I've started from R of s, I've traveled till C of s, the straight line. You can see the direction, all are in the same direction, unidirectional. Okay, the next thing you might be, so we have only one forward path. Okay, so for that I'll write T1 is equal to gain of that, multiply the gains G1. So 1 and 1, if you multiply with this, it is again the same thing, so no need to write 1 and all. So just G1, G2, G3, G4, G5, just multiply and write. That is nothing but G1, G2, G3, G4, G5. Now the thing is that you might be getting one doubt here. Can I start from this point and travel till this point and take this path back to this node and travel to the C of s? So basically what am I telling is, starting from R of s, going to one node and taking the reverse path, going to another node and taking and reaching the destination C of s. Now this is possible way. Okay, this is one possible way, but the thing is that you should not, one more condition is that for the forward path you should remember one more point, that is you should not repeat the nodes or the path. You should not repeat the path or the nodes. This is one important point. So see here, starting from this point, taking to this point and taking the reverse thing, and you are again traveling to the same path or the same node again. So you are traveling to this path twice. So that is not, we cannot consider that as one forward path. For this case also, if you travel from this point to this point and taking this path, so try to understand this one, that you cannot take the reverse path and travel to the same path or the same nodes, you cannot repeat. Okay, so you have to travel in the same direction, all the direction you have to see. So there is only one path for the given forward path for the given signal flow graph. Second step is to find out the individual loops. So in order to find individual loops, what you have to do, individual loops basically means loop in the sense we start from a node, travel and come back to the same node. That is nothing but the loop. That means starting and the ending point should be the same. If you start from this node, you have to reach this node at the last. Okay, so starting and ending point should be the same. If you observe this loop G1 and minus H1, so let me show in this signal flow graph. So you can see here the first loop you observe, here you observe this is G1 H1. This is the loop I have considered here. This is a loop because if you start from this point, okay, observe there, I'll start from this point, I'll travel to this node and I'll travel back to the same point. Correct? I'll travel back to the same point. Starting and the ending point is the same. So I can consider this as a loop. So this is the L1 loop. I'll consider that gain I have to multiply and write. G1 is there, H1 is there, minus sign is there, minus sign I'll take it outside, so it is G1, H1 and minus sign is there. Next, second loop I'll consider G3 and H3. So you can see here, this is the loop. Okay, this is the loop, this loop. G3 and H3. So starting from this node, and you can start from this node also, not a problem. Okay, if you start from this node, you are traveling to this node, then coming back to the same point. Starting and ending point of this should be the same. So I'll start from this node, going to this node and traveling back to the same node. That is nothing but the loop. So I'll consider this as the second loop. Let us go to the third loop that I have got. Here you can see one big loop, correct? Here you can see the big loop. So basically this loop I can consider. So starting from this point, you can start at any of the node. Okay, you will arrive at the same position. If we start from this node, observe. Okay, we will start from this node, going to this node, then going to this node, traveling back to this node and reaching here. That means starting and the ending point is the same. Okay, you can choose any node and travel, you will get the same starting and ending point. So this I can consider as a third loop. It doesn't matter, one more thing, it doesn't matter if you consider this as L1, L2, L3, anything you can consider. Naming doesn't matter. Let us go to the fourth loop. So how many possibilities? In this signal flow graph, we are getting 5 loops, 5 individual loops. So here, let us go to the fourth one, that is G4 and H4. So this you can see, this is one small loop, correct? G4 and H4. So starting from this node, going to this node, traveling back to this node. That is the thing with the loop. Next, this I will consider L4. Next, the last and the final loop, which is something but here you can observe one small loop is there. Okay, so this I will consider as the L5, that is G5 and H5 minus sign is just multiply. Starting and ending point will remain the same. Now this is what I have done. So this is the second step. You have to write the individual loops and gains you have to write. The thing is that you have to write the gains. Just multiply and write the gains. Next, we will proceed to the third step. You have to find out the delta value. As you know, in the transfer function, I have the formula summation of tk into delta k by delta, in which in the denominator I have delta. So that we will find out in the third step. So delta, we have one formula. Before seeing this, we will see the formula first. Now for all the problems, it remains the same formula. Okay, so delta is equal to 1 minus sum of individual loop gains. Individual loop, whatever we have considered. Here I have 5 loops. Okay, so that loop gains I have to sum, add it up. That is the thing. Plus summation of gain product of all possible combination of 2 non-touching loops. This is important. You have to see 2 non-touching loops minus gain product of summation of gain product of all possible combination of 3 non-touching loops. Okay, 3 non-touching loops plus then again same thing, summation of gain product of 4 non-touching loops. Now what is this non-touching loops? That we will discuss. So the thing is that to remember easily, you can see one minus sign is there, then plus sign will come, then after this minus sign, then plus sign, then minus sign, like that it will go. Now the first thing, sum of individual loop gains, you can directly see from this. So sum of 1 minus sum of individual loop gains, that means L1, L2, I have 5 loops, I have to add it up. That means I have, in place of L1 I have to write the gain. Don't write L1 and L2, it should be in terms of gains. So then in the next step I will write L1, what is that, gain, L2, L3, L4 and L5 plus what was this, it is gain product of all possible combination of 2 non-touching loops. Now thing is that 2 non-touching loops you have to understand. Non-touching means the loop should not touch. 2 non-touching loop means I will consider 2 loops. Okay, first loop like this, second loop like this. So remember this, the nodes should not touch each other. That's a simple thing. The 2 non-touching loops I have to consider that should not touch each other by just seeing the nodes. You can just see the nodes if they are not touching to each other. Suppose this is a loop and one more loop is overlapping to this. So this loop is touching somewhere, right? This node. Okay. So you can observe that these 2 are touching loops, 2 touching loops, but I want 2 non-touching loops. So I have to consider the first option, not the second one. So for that I have drawn separately So you can see here I have all the combination of two non-touching loops. Okay, so see till here. I'll start with first one, L1 and L2. These two are I can say two non-touching loops. Why? Because let us go back to the signal flow graph. G1 H1 G3 H3. Now observe carefully. G1 H1, this loop and this loop. You can observe that these two loops are not touching each other. Correct? These two loops are not touching each other since the nodes, they are separated, right? So this two is a pair. We have got one pair of two non-touching loops. So L1 and L2 will be a pair of two non-touching loops. So first one we got. Let us go to the another combination, that is G1 H1, that is this loop again with G5 H5, this one. This loop and this loop, see, they are far away, they are not touching each other, right? Nodes here you can observe they are not touching, so I can consider these two as one pair of two non-touching loops. So this one over. Next we'll go for this one again, G1 with this one, this loop, this small loop, they are again not touching. So I have considered G1 with this, then this, then this. Okay, so three combination I have got. This are non-touching. Another combination I have got here, that is G3 H3, that is this loop with this loop, this and this. Observe here, this loop with this loop, that is nothing but non-touching loops. Correct? The nodes are not touching, there is a space in between this. So these two loops. Now again the last and final combination I have got. So you have to search for the combination. Okay, that's the thing. The bigger loop, that is, you can observe this bigger loop with this loop. Correct? This bigger loop, I cannot consider this loop and this loop because there is a common node, so that is touching. So that will be two touching loops, but I want two non-touching loops. So this bigger loop and this smaller loop I'll consider. Okay, so that will be another combination of two non-touching loops. So I have got 5 combination of two non-touching loops. Now in the formula we have one more thing, that is nothing but you have to take the combination of 3 non-touching loops also, that is a minus, then again I have, so I have found out the 2 non-touching loops. I have got 5 possible combination. Next thing is that you have to find out the 3 non-touching loops. So you can see here I have got 3 non-touching loops, L1, L2, L5. So let us go back to again the this thing. So I'll just mark it here. This is L1, this loop you observe, then we have this loop and we have this loop. So basically I'll just tell you, this is one loop, this is another loop, and this is the third loop. You observe carefully, these 3 are touching? No, they are not touching. So this is the three non-touching loops. So combination of 3 non-touching loop, I have only one pair. So that's what I have done here. I have got only 3 non-touching loops, only one pair I have got. Okay, that is the thing. So always remember, 2 non-touching loops, you have to take one pair as two loops. So the combination for 3 non-touching loops, you have to take the combination of 3. So let us now write the formula. That means, see here, 1 minus sum of individual loops I have written, that we have discussed, plus gain product of combination of 2 non-touching loops. Here the thing is that, see, this is one combination, this is another, this is another, this is another. We have got 5 combinations, that's we have discussed, and we have to add them. So loop, you have to multiply gain product. That's what I said, gain product, summation of gain product. That means sum you have to do and you have to multiply the loop gains. Now in the place of L1, L2 I have to put these values. Okay, that I'll do at the last. For the explanation purpose, I am just writing as L1, L2 plus L1, L5 plus L1, L4, that we have discussed. You see here, L1, L2, L1, L5, L1, L4, then L2, L5, L3, L5. This all things I have to add it up. Add, and that's all. Okay. So multiply and add. Then minus gain product of possible combination of 3 non-touching loops. Now the thing is that three non-touching loops, we have got only one combination that you can see over here, that is L1, L2, L5. So I have to multiply, so I have just multiplied it, plus nothing is there. We have got no like in this we have got only one combination, so I have to leave it till here. That's all. Okay, four non-touching loops possibility is not there, so you can try it once. You search for four possibility, four non-touching loops, it is not possible, so we will stop it till here. Now let us go for the next step, that is to find out the step 4 is that we have to find out the delta 1 and delta 2, but in this case delta 2 is not there, since I will tell you the sum transfer function formula is given as summation of tk delta k by delta. In this we have found out delta that we have done. Now tk and delta k, what is that? If a number of forward paths is 1, so I will consider it as what? The formula becomes t1 delta 1 by delta. This will be the formula. If forward path is 2, that will be t1 delta 1 plus t2 delta 2 by delta, like this. Okay, so we have got only one forward path, so our formula will be t1 delta 1 by delta. So I have to just find out t1, not delta, I have to just find out delta 1, not delta 2. So cancel out delta 2, so I will find out delta 1. How to find out delta 1? Simple thing, we have another formula for that, so let us just see that formula. See here, it's the same formula as delta, but the thing is that delta 1 will be respect to t1. So t1 is equal to 1 minus sum of individual loop gains. This we have discussed in delta also. It's the same formula. You can see here delta formula was 1 minus sum of individual loop gains, but here one more additional thing is there, which are non-touching to t1. So that's what I said. So for delta 1 the formula slightly changes, that is nothing but with respect to t1 you have to find out. So sum of individual loop gains which are non-touching to t1 plus gain product of two non-touching loops with respect to t2, like that it goes on. So with respect to t1 t1 you have to find out delta 1. Okay, delta 2 no need because we have only one forward path. Now the thing is that delta 1 value is 1 minus sum of whatever loops we have. So see, observe here, I have got all the individual loops, correct? All the individual loops I have got. Now here the thing is that if you try to analyze this one, see here which forward path I have, this forward path. Now from this we have to find out the individual loops which are not touching to this forward path. You can see that all the loops, there are 5 loops, correct? 5 loops we have considered. Here you can observe we had 5 loops. So this all 5 loops are touching this forward path, right? If I try to draw all the forward paths, this is one loop, another loop is this one, then another loop, then another loop. All the 4 loops are touching, and the bigger one also is also touching. Okay, right, the bigger loop is also touching. So I can say that there is no loop which is not touching to which one? Forward path t1. So I can write this as 0. Okay, then if no loop is touching to this forward path k, that is t1, then no need to go for the next that is in formula wise we have to go for the 2 non-touching loop case. So no need to go for that. The thing is that I'll repeat, if you are getting this as 0, then no need to go for this. That's it. So sum of individual loop gains which are not touching to, so you have to find out the loops which are not touching to the t1. So we have no loops which are not touching to t1, so it is 0. So hence since it is 0, so no need to go for this one. Next we have the final step, that is nothing but Mason's. So this will be delta 1 will be 1 minus nothing, so it is 1 itself. Most of the case you will get it as 1. Okay, so step 5 is Mason gain formula that we have discussed. CFS by RFS is nothing but the transfer function which is equal to t1 delta 1 by delta. Okay, so we have given always remember transfer function, it will be in terms of g1 gains only, g1 h1 whatever is that gains only. Don't write here L1 loop 2 and all. Okay, so t1 I have written the loop gain. Okay, I have written loop gain. Next t2 we have not t2, delta 1, it is 1, correct? Then delta is nothing but 1 plus, see this is what I have done, it is L1 L2, L3, all the things I have substituted here. So just observe this, try to analyze this part. So I'll just, okay, fine. So what I have done, in place of delta, I have written, I'll show you again, delta is nothing but we have got 1 minus L1, bracket you have to put, okay, L1 plus L2 plus L3 plus L4 plus L5 plus L1 L2 this thing minus this thing. So in place of L1 I have substituted this value, L2 this value, L3, like that I have done all this thing. Okay, so this is in the denominator, all the things is the denominator. Only numerator we have only T1 delta 1, that is nothing but this part. In denominator I have all these terms. So just observe carefully. So this is the final answer.